Hallo, hallo. Hallo, hallo, hallo. Okay, hello. I hope everybody had a nice lunch. Actually, I overslept lunch. I took a power nap. So good. Um, yes, obviously, I chose the right buzzwords in the title. That's good. So now I can basically talk about whatever I want. Um, but I decided to go through with this, and I will talk about how I used machine learning in a hobby project. Usually when we learn something in our work, uh, we start probably with some kind of tutorial or book. Somebody has done the work for us already. We just Google, and then hopefully we find something useful and we replicate it. And if we are lucky, then we get the same output, and then we have learned something. But what I wanted to do is, I wanted to level up. I wanted to be like this on the right-hand side. Instead of a baby just being spoon-fed, I wanted to have my own spoon, and I wanted to be able to manage it by myself. Still kind of messy, still kind of dirty, but a bit more power and a bit more skills. And eventually I will be even more clean later on, but not yet. And this is basically what this presentation is about. It's about my journey to machine learning. And I will show you during this presentation how to find suitable data. Then I will obviously introduce my little hobby project and the data that is handled there. I think the data is probably something that everybody in this room can relate to. Then I will show the pain point that I experienced and that I'm trying to address and solve with machine learning. My name is Martin. I am a software developer in Gothenburg. I have been developer for the past 14 years. I have worked mostly with Java, but also with other things on the side and in different branches. Currently, I'm focusing on telecommunication, and other than that, I'm very much into technical depth and machine learning, as well as the soft factors of development, like knowledge sharing and so on. If you want to tag me, feel free to use that Twitter handle. I have to admit, I'm one of the worst Twitter users ever, but if you want to tag me, feel free to do so. Okay, data. When we want to work with machine learning, data is probably the most important thing. Without data, we would not be talking about machine learning. And then I figured where to start. What can I use actually? First, I figured I could maybe use data from my daily work, but that's probably a bit tricky because I don't own the data and it might be sensitive data and I cannot use it. Probably there will be legal issues, most likely. Another option could be to use some kind of API. There are a lot of alternatives out there. Or I could use my own data. Luckily, I have some data, so I chose this route. But if you are interested, you can go to this site. I compiled a list of potential data sources where you can start, and maybe you find something interesting. There's a lot out there that can be used. Okay. Next is a short and quick introduction to my project. Just to show you what is it about, and then I will demo it also quickly. The main idea for me was I wanted to learn some tech that is unknown to me, something that I'm not doing in my daily work. I mean, when you work with web development in your daily work, then it might be nice in a hobby project to shift the techniques a bit, just to keep it spicy. And for me, I was surfing quite a lot, especially during the pandemic. There's pretty much not anything else that I was doing sometimes, so I collected a lot of links, and I wanted to keep track of content. Now you could say, aren't there any tools already? I mean, every browser has options for bookmarking and so on, but I have to admit, I suffer from not invented here syndrome. And yeah, let's face it, that's also the beauty of hobby projects. You just can do what everybody else has been doing just for fun. And as I said, it was a lot about surfing and URLs. So two of the main domain concepts that I use in this application are links and categories. And with links, I basically mean URLs, and I enrich that data with some description, some title, and some other metadata. And I'm a bit of a nerd when it comes to labeling things, categorizing things. I would like to have things sorted. So I introduced the concept of categories so that most of my URLs that I collect have some kind of category and everything is neatly sorted. And now I could basically show you just a big table. That's not what I want to do. Instead, I show you some visualizations so that you get at least some idea of the content of this database. I keep the screen a bit smaller so that we can together focus on one graph at a time. What you see here is on the top the amount of links, currently around 1500, and they are divided into 74 categories. And the first graph shows basically how the links are distributed. I wanted to know which categories are the largest and which are basically empty. And what I can do here is I can move that slider to set some minimum value. Let's put it to 50. And now you see a little bit more detailed what kind of links I have in this database. So obviously I seem to have a lot of links connected to Java development. But I also have Spring Boot and machine learning. So this view gives you already a bit of an idea what I might be interested in. If we go to the next graph, it's a bit more detailed. Here I'm not looking at categories, but the actual words. URLs consists of words basically. So this is a bit more truth than just categorizing. If I move that up a bit, let's say also 50. Again, it seems like there were a lot of links connected to Java and a lot of links connected to Stack Overflow. So basically, you could say that I might be a Java developer and I might hang way too much on Stack Overflow and I might have way too much questions. And what you can see here also is that here you see also kind of meaningless words like to and. So these words would be actually more suitable to be sorted away. I will talk a bit more about that later. Then I have two more graphs. This is not so much about the content, but more metadata. On the left-hand side, you see a pie chart about when the links have been created, at which weekday. And on the right-hand side, you can see a graph at which hour of the day I have created this. So based on these graphs, you can say most likely I'm using that tool on Sundays, also on Saturdays, which is kind of logical because this is the time when I actually have time for working with this. And we see that not so much links are created between 2 AM and 8 AM. This is also kind of obvious because that's hopefully the time when I'm sleeping. And this is basically one takeaway for me when I was working with this. Before going into real machine learning, it's good to look at the data from different angles, connecting different pieces together, looking from different perspectives to get some kind of insights. Based on that data, we know again that I'm a Java developer with a lot of questions, and that I sleep between 2 a.m. and 8 a.m. Now, when you work on a hobby project, you are probably kind of proud that you accomplish things. I got less self-critical because things are working right, so cool. I can work on my GitHub statistics and just push. But then eventually, when I'm really honest with myself, I detect some kind of pain points. And one of the pain points that I discovered will be shown in this very short clip. Hopefully it's working, but it's without sound. So here comes the cursor. Obviously I'm trying to change something. Seems like I want to change the category. Earlier it was Java programming, and now I want to switch to Spring Boot. Did you see the pain point? From a user perspective, I think this is not so good in the end. As you have seen earlier, in the database there are 74 different categories. So basically what I have to do each time when I want to reassign a category, I have to scroll through a list of 74 items. And if I create more categories, then the list will be longer and longer. So this is nice as long as it's really test data. Let's say 5 categories, that's not so harmful, but over 70, that's basically a failure. So let's go to full screen again. Okay, now I have identified some pain point. Now it's getting a bit interesting. Now it's time to take the next step. What do I want to do with the data? And I found a very interesting chart on Instagram, and I adjusted it a bit. What you can do basically is ask, what kind of questions do I want to get answered by my data? Maybe the question is, what should I do next? Then we are talking about reinforcement learning. An example could be some sprinkler system that's getting turned on, turned off based on different measurements. Another question could be, is it weird? Is it strange? Then we are talking about fraud detection, for example. Most likely we have seen it already in our credit card payments. If there is an unusual payment, then it might happen that the credit card gets blocked. Another question could be, is it A or B? What should I choose? Then we are talking about classifications. Is the question how much, how many? Then we are talking about regression. And if the question is how is something organized, then we can look into clustering. And for me, I decided to go for this option. I want to be able to classify the links so that I get a informed support which categories I should choose. And now it's getting interesting because now we are talking about math. One simple classifier is the so-called Bayesian classifier. It goes back to a mathematician called Thomas Bayes. And this Bayesian rule is basically about calculating probabilities. And in this formula, we are basically calculating the probability of A given situation B. And to understand that best is with a simple textbook example for starters. You can find similar examples also in a lot of tutorials. But here the question would be, what is the probability of a patient having a liver disease if she is an alcoholic? So basically what we have to do here is we have to find numeric values for these variables, put them into the right place, and then we can calculate the probability. So A in this case stands for patient has a liver disease and B stands for patient as an alcoholic. And then we simply have to define here what the different variables mean. And last but not least, just to find values. Most likely these values are measured. And in this case, the hospital has collected some data, and we see that 10% of the patients have liver disease, 5% of the patients are alcoholics, and 7% of the patients diagnosed with a liver disease are alcoholics. If we put these values into the formula, the result would be 14%. So this is only a textbook example. Now I want to apply similar things on my data. A question would be, in that case, what is the probability of a link belonging to, let's say, category Java if the link contains the word developer? And similar to the previous example, I just have to define what the different variables stand for, and then I can have a calculation. Now I will again go back to the app and demonstrate it here. In the earlier example, we choose this link. I will open it. And here you see a similar view as before. We still have this drop-down box where we can choose out of 74 different categories, but now I introduced some suggestions. And these suggestions are basically a list of categories and their probabilities. So based on this data, the link should actually belong to Java programming, because that has the highest probability. And now I can simply choose whatever the application is recommending, instead of me having to think, ooh, is this more Spring Boot, is this Java, is it something else? I get a list presented and I just can click, click, click without thinking. And that's making it much smoother. But one thing I was wondering when I was working with this is the very small values. As you can see here, there are numeric values after each category name, and these values seem to be very, very small. But why is this? Let's go back to the presentation. Actually, the formula for calculating the probabilities is a bit more than just these three values. You see in the middle here this Greek letter, which is the mathematical symbol for products. That means here is a whole collection of different probabilities that are multiplied. Not just two, but it can be for each word in the URL. So it might be 10 different values that are multiplied together. And of course, it can happen that some words would result in a value that is equal 0. And that would mean that the whole product is getting 0. I mean, if you multiply a lot of values and there's 1 0, then the whole product is 0. And to avoid a lot of values ending up in 0, the Bayesian rule uses something that is called smoothing, not smoothing. Smoothing means we are using some some fake value that is very small but still larger than 0, and that means that the total value will be very, very small. That's why it was exponential minus 18, for example. If we go back to the example, here we see the largest value is exponential minus 18, and the lowest value is exponential minus 24. But still, we have accomplished something. We have a list of probabilities. We have some candidates that are more suitable than others. And we can more simple choose the right category. Okay, so the main mission for me was accomplished. Now I have a possibility to get suggestions. I don't have to think too much by myself. I just can click, and that makes life so much easier. Next steps would be to improve this existing classifier. And as I mentioned earlier, in one of the graphs we saw some meaningless words like to and. These words should not be considered as relevant for calculating probabilities. This could be one thing that could be improved. Then we are talking about so-called stop words. These words are usually excluded in all natural language processing routines. The problem here is I have, unfortunately, links in 3 different languages. So this can be kind of tricky. For example, if we take the word is in English, that would be a classic example for a stop word. But if we are thinking Swedish, it's a noun. It means ice, basically. Then it should probably not be considered as a stop word. The same would be the word die in German. In German, that would be a good example for a stop word, but in English, it would mean die. And that could be a relevant word. Another thing that could be improved are so-called n-grams. N-grams means basically a sequence of different words, which words are showing up together pretty often. That can be a factor. And then, last but not least, there is a term called lemmatizing, and that means we are treating inflections of a word in the same way. For example, developer and development. This could be counted together, so the probability would be affected by that. Next step for me would be to try total different classifiers. One example here would be the so-called support vector machine. That's another quite simple classifier, and then I could basically have them compete with each other, and then I can choose which of the classifiers would be more suitable. That's the beauty of hobby projects. You don't have product owners, you don't have stakeholders. You simply can make your own choices and go with it, if you find the time. And then, of course, it would be interesting in that case to try some clustering, just to leave out existing categories and just try to find connections between different links and see what would be the sorting. Then how would the data be grouped? Is there some other connection that I'm not seeing in my current data set? So that's basically also an alternative. Okay, this is basically it. I can say that was a really fun experience so far, and I will definitely continue with it. What I have shown here in this presentation, I showed some lightweight strategy or help for decision making, how to find the data and what to choose, what kind of routines to choose based on the data and what answers I'm looking for. For me, it was also interesting to do it a bit the hard way, not relying on existing libraries, because that makes it more efficient maybe, of course, but it's a lot of black box working. So this is gives much more understanding when you do it by yourself. And I think there is a lot of potential to continue in the end. And as I said, in this case, I would be the product owner kind of, so I can choose whatever direction I feel like. And that's good. Okay, that was it for me. Thank you very much. Are there any questions? Yes?
Your Bayesian model, is it trained once, or does it update on the fly? Repeat the question.
Yep, the question was, is the training done on the fly? And yes, the answer is yes, the data set is so small still, then the training can happen on the fly. But we will see how it goes. If I have, let's say, 10,000 links, then it might be good to have a more machine learning approach.